Nicknamed America's pastime and enjoyed by millions around the globe, the beloved sport of baseball has entertained generations of fans. But before the pros can hit the field, they have to get their practicing in. During training, players often use what's called a soft toss drill to improve their swing and their coordination. One person tosses a ball up in the air, and the batter tries to hit it. In a split second, this practicing technique forces the batter to make a lot of quick decisions, like when to start swinging and how to angle their bat. It's hard enough for a person, but the real question is, can a robot do it? It's an interesting question and potentially one with useful implications. The task of getting a robot to successfully complete a soft toss presents a unique challenge, given that the mechanics of a swing are so complex. And it opens the door for automated assistance during baseball workouts, since players might also want to practice fielding the balls that the robot hits.
This part of the video is about the robot simulation in VRAP. The code were written in Lua script, and for our project, there are three major components need to be implemented. The first part is the shooting ball mechanism, and it's very simple. So as you can see, the ball was supposed to shoot in the YZ plane toward the batter, so we just simply give it a proper initial velocity in both Y and Z directions. The second part is the batter. The inverse kinematic was implemented on the robot arm, and the end effector was set to the middle position of the bat. The proximity sensor in front of the batter could sense the ball when the ball approaching, and to successfully hit the ball, the batter has to hit the ball at its predicted position rather than its current location. And this is accomplished with a simple formula. The last part is the catcher. Rather than directly accessing the ball's instantaneous position as the batter did, it accessed the position of the ball through the vision sensor right on top of the chessboard. And you can think it as a satellite to help locate the ball. Similar to the lab, we use the blob detection to detect the ball and rate its location in camera frame and convert it to the word frame to locate it. An interesting part on this catcher is a way to chase the ball. So there are multiple ways to approach this, and my solution is to implement 3 GPS parts at the front, center, and the rear of the Pioneer mobile robot. So as you can see, the connection of the front and rear node has to be collinear with the line connecting the center and the goal point in order to face the correct direction. So whenever the connection mismatched, the car's left and right motor has to run at the different speed in order to turn the robot back to the correct direction. So this project is medium challenging but quite comprehensive on covering a lot of aspects from the course. Personally speaking, playing around with the parameters to create different scenarios is the most interesting part of this project.